So the next thing we have to learn about is all of the rules. Rules are so fun. If you remember, if you have e to the x and you derive it, what do you get? You get e to the x. So what do you think happens if you have e to the x and you're integrating it? Nothing. You get e to the x plus c. Or if there's bounds on your integral, and if you're plugging in numbers, then you plug in numbers, obviously. But if you're just integrating e to the x, it does not change it. You end up with e to the x. Second thing, if you remember, if you derive ln x, you end up with 1 over x. So what do you think happens when you integrate 1 over x? If you try to integrate this normally, you would have x to the negative 1, and then you would try to add 1 to the exponent, right? So you get x to the power of 0 over 0, right? You can't do that. You can't put anything over 0. So when you're integrating 1 over x, you just end up with ln x, right? Because it's just the opposite. Ln x turns into 1 over x, so 1 over x, when you integrate it, turns into ln x. If you have something like 5 over x, or you have something like 2 over x, what this turns into when you integrate it is 5 ln x or 2 ln x. Whatever the numerator is, you can just put in front of the ln x, and it works. Now we have to cover the integrals of all of the trig functions. If you remember, this is the same thing we did before, but it's just backwards now. Cosine x is going to turn into sine x plus c. All of these are going to have plus c. Sine x turns into negative cosine x plus c. Secant squared x will turn into tangent x plus c. Cosecant x, cotangent x will turn into negative cosecant x plus c. Secant x tan x will turn into secant x plus c. And cosecant squared will turn into negative cotangent x plus c. These are all things that we already learned with the derivatives. It's the same exact thing but backwards, so that's why I'm going over it kind of fast and with messy handwriting. That's why the handwriting is messy, not because no other reason. Okay, that wasn't the last thing. This is the actual last thing. If you have a function x squared plus 4x plus 3 over 2 dx, and you have to integrate this, how would you do it, right? You have this 2 on the bottom, and it's like a big fraction. Is there like a integration quotient rule? The answer is no. You would just separate it to make it easier, and you just do 6x squared over 2 plus 4x over 2 plus 3 over 2, and then integrate it like this, like you normally would, adding 1 to the exponent, dividing, whatever. You cannot do this if you had like 2 over 6x squared plus 4x plus 3, right? Because you can't just break up the denominator. It doesn't work like that. You can only break up the numerator. Also, if you had a function that was like 4x times 3x squared plus 2, right? How do you integrate this if there's 2 different terms? Do you do integral product rule? No, you don't. You should just multiply it out and get 12x to the third plus 8x. And then integrate it like this, because this is a lot easier. I'm going through these really fast because rules are boring. Also, I think most of these are pretty straightforward. That's it for the rules. We're going to learn about cool integration using u sub. So we moving on.